Okay, so we're going to find the mode for this data set. So notice that 28 occurs 3 times, 54 occurs 3 times, 63 occurs twice, and 89 only occurs once. Okay, so once, twice, 3 times, 3 times. So I need the greatest frequency, so that would be these two. And they're the same greatest frequencies. So this one would have 2 answers, so this would be bimodal. And your 2 answers would be 28 and 54. Okay, now if I did this right here, if I added one number, say I added 63, well then the 28, the 54, and the 63 would have occurred 3 times. Therefore, have multimodal for, and your answer would be 28, 54, and 63, because all 3 of them occur with the same greatest frequency. But for this one, it's bimodal, 28, and 54 is your final answer. Okay, this one, this occurs once, once. So no repeats, which means no mode. And that's your answer for that one. Okay, now what you need to know for this slide is if you have got nominal data, then the only thing that you need to use is the mode to describe the middle of the nominal data. Okay, and it could be the mode can be calculated for qualitative data as well as for quantitative data. Say we were looking at, say we're at a snack bar. Say we had M&Ms, another M&M, Butterfinger, Twix, and we'll say 2 more Twix. Okay. Now the reason why you'd want to use the mode and not the mean or the median is, number one, for the median we'd have to put these in order first, but I don't even know how to put these in order. Okay, so it doesn't make sense to use the median there. For the mean, what is an M&M plus an M&M plus a Butterfinger plus a Twix plus a Twix plus a Twix divided by 1, 2, 3, 4, 5, 6? Besides diabetes, what would that be equal to? See, that doesn't even make sense either. The only thing that makes sense is finding the mode. Well, which one occurred with the greatest frequency? Well, the Twix, because this occurred 3 times, Butterfinger occurred once, and M&Ms occurred twice. So for nominal data, or for data that can be put into categories, you got to use the mode. Now, if you've got ordered data or ordinal data, the only thing that you can use is the median. Okay. And last, if it's interval or ratio data, the only thing that makes sense to use is the mean. Those are the takeaway slides, or the takeaway items from those 2 slides. Then we get into, well, when do we use the mean versus the median, depending on our data distribution. If you have symmetrical data or symmetrical distribution for your data, what you need to use is the mean. If your data is skewed, use the median. And this is what I mean by skewed. Your data is pulled to the left or to the right. It's not a mirror image of each other like this one. So this one right here is symmetrical. These 2 on either side would be skewed data. Okay. Now the reason is why you wouldn't want to use the mean for your skewed data is your mean is going to be drastically affected by all these values over here. And it's really affected by an outlier. Because your mean incorporates every single number. You add all the numbers up and then you divide by how many numbers you had. So your mean will include all of these numbers over here and say, okay, the middle is right here, when really most of it is right here for your data. Now your median doesn't look at every single number, it just finds the middle 1 number or the middle 2 numbers and then takes the average of them. depending on if you have an even number of data versus an odd number of data, like we've already talked about. Okay? So if we look at this one, in a sample of 60 households, one house is worth 2.5 million. Half of the rest are worth 280,000, and all the others are worth 315,000. Which is a better measure of center, the mean or the median? So we could draw this out. We could say, okay, right here is 280K, 315, and then way over here is the 2.5 million. One person has 2.5 million, okay? And then we'll say half, the rest of the people, half of them have 280K and the other half have 315K. So what your distribution would look like is something like this. Okay, so since it looks like this is skewed by definition. More of your data is over here towards the left. So since it's skewed data, that means the only thing that I can use is the median. Okay, now if I had taken out this right here, because what this is known as, since it lies far away from the data, is an outlier. If I take out this outlier, then what it looks like, basically like that. There's your 280, and then there's your 315. Then I could use the mean for this distribution because it would be symmetrical. But for this one with the outlier, the only thing that I can use is the median because it's skewed. Suppose that in a small town of 50 people, one person earns 5 million per year and the other 49 each earn 30,000. Which is a better measure of the center, the mean or the median? Well, this is the same thing as the last case. You've got people here that are earning 30K, one person that is earning 5 million. Okay, so it would look like that. So since this is skewed data, the only thing that you can use is the median. And again, if I took out this 5 million, which is an outlier, if I took out the 5 million, then you would have something like this right here. It would be symmetrical, so you could use the mean then. It's something called the mid-range. It's a really simple formula. All you have to do is take the max plus the min and then divide by 2. It's midway between the max and the min data values. So if we look at this one right here, we're going to find the mid-range. Well, I need the max number, which looks like 26, plus the smallest number, which is 22, and then divide by 2, give you 24. So 24 will be your final answer. Say you have a frequency table and someone asks you to find the mean for that frequency table. So we're going to take the definition for finding the mean, which is adding up all our data values and then dividing it by the number of values that we had and tweak it just a little bit. Okay, so what we're going to do is for every point within the class for your frequency table, we're going to find the midpoint and we're going to take that and multiply it times the frequency for that class. Do that for every single class, add the numbers up, and then divide it by all the frequencies. Okay, so like this one, here's my table right here. Each of these are my classes. So I have 1, 2, 3, 4, 5 classes. And here's the frequency for each and every class. Now, for the class 50 to 69, it says a frequency of 2. So there's 2 numbers between 50 and 69. I just don't know what number that could be. It could be 2 68s. It could be a 51 and a 65. I really don't know what numbers they're talking about. They just say there's 2 numbers that occur between 50 and 69. So what we're going to do is we're going to take a guess and say we're going to find the midpoint and use that for a frequency of 2. Okay, so to find the midpoint, what you're going to do is you're going to add these 2 together. So you're going to have 69 plus 50, and then divide by 2, and that's going to give you 59.5. Now the easiest thing to do once you get this number is to look at your class width, the difference between these two numbers, 70 and 50, which is 20, and keep adding it to this number right here. So then you'll have 79.5, and then 99.5, and then 119.5, and then 139.5. So what we're essentially saying is, within my data set, I have two 59.5s. I have 33 79.5s. I have 35 99.5s. I have 7 109.5s. And then 139.5s. Now what we're trying to do is we're trying to find the mean. And since we have some repeats, we can use that shorthand version. So I'm going to get rid of this part right here. So that was 59.5. Write that 5 a little better. So I'm going to take the frequency of my data value, multiply it times my data value for every single one of these. So 59.5 times 2 would be 119. 79.5 times 33 will be 2,623.5. 99.5 times 35 will be 3,482.5. And then 119.5 times 7 will be 836.5. And then 139.5 times 1 will just be itself. Okay. So then the last thing I need to do for this column right here is add all these numbers up. So this would be the summation of your frequency times your midpoint, which will come out to 7,201. And if we go back to our table, or our formula here, I just did the top part. Now I need the bottom part, the summation of all my frequencies. I'll come right here to my frequencies, and I'll add all of them up, which you should get 78. Okay, so now our mean will be 7,201 divided by 78, which will give us 92.3. So this would be our expected value for the mean of this distribution table right here. So that'd be your final answer right there. So this over here, all these numbers over here, we add them, right? So this is really just the top part of, let me get back to it. Not this, but this right here. Okay, what we just did was the top part of this. Okay, right here. That was this part right here. Then once we added all our frequencies, that was the bottom part. And then we divide those two numbers, and that gives us our mean. That's essentially what we're doing here in our other example. This one right here. We're just breaking it down step by step.